So we're going to continue with our unit testing. So we'll be a little bit repetitive about this just to ensure we get the hang of it. So I'm just going to quickly check. Like I said, I'm going to run my code coverage analysis again. It's probably not going to update any of the numbers because we already had one test. Yeah, so it's still, if I drill down into my controllers, it says my home controller, yeah, my index is 100% covered. About and privacy are still at 0. So let's unit test let's unit test privacy and about as well, just so we start to get the hang of it. We'll be a little bit repetitive, and then we're going to have to do some more advanced testing. And we should see if we can unit test these two methods as well. We should see that our home controller will go up from 14% to closer to 50%. So let's write 2 more tests. And they're basically going to be the same as our index one. So I'll create another test method, and we'll call it privacy loads the correct view. And our code is going to be identical to the method above, except we're going to call index, we're going to call privacy instead of index. And we're going to check that the result we got back is called privacy. So we'll arrange. Again, we'll create a new controller. We'll act. So this time, instead of calling the index method, we're calling the privacy method. We'll cast the result as a view result object. And then we'll do our assertion. We'll make sure that the view we get back is called privacy. So it's exactly the same test. I've just changed the method name here and the name of the view we're expecting. And now my test explorer says, okay, hey, you've got a new test that's never been executed. It's got a little blue info icon. I can run them. So we'll run the test, and it fails. Stephen, why did it fail? So in our controller, our privacy, so notice it says here now we have 0 of 1 passing. So there's one test of this method, and that test failed. So inside our privacy method, we'll also want to explicitly name the view we're going to load as a string. Before I save it, I'm going to enable one other feature, which is kind of neat. If I go to my test method at the top, there's live unit testing. So if I click start, that means anytime I change a method that's covered by a unit test, as soon as I save the changes, the test will automatically run. I don't have to manually do the tests again. They're going to run every time I make a change. So I'll start my live unit testing, and as soon as I click save, it'll rerun my test. Maybe thinking about it down here. So it's going to run my test again. Now that it's saved and rebuilt, now our test passes. So we don't have to enable that live unit testing, but it just saves us a step of making a change, running the test again. The test will automatically execute if we turn it on. So we're going to unit test about as well. So while we're in here, we may as well add to our about method, let's add the name in the return view statement as well. So we can save that. And now we'll need an about unit test. That's going to be pretty much the same. We'll actually do one thing to simplify it, our unit tests a little bit. So now all of my return statements have the name of the view. And I'm going to go back and write one more unit test. We'll create a new test method. We'll call it about loads correct view. Now the one thing we can simplify is the arrange. Notice every one of our methods, we've got the same arrange statement over and over again. So the unit test class, all our methods so far have this test method annotation. There's also a special method we can create called test initialize. And that method will get called before every single unit test. So rather than us creating the home controller in every method, we can move this to an initialize method, and that initialize method will automatically execute before each test. So that will save us from having to repeat our exact code over and over again. So I'm going to put this right up at the top of my class. It doesn't have to go there. And we use, instead of test method, I use this annotation, test initialize. So this method runs automatically before every test. So this line of code, creating a new instance of my home controller, we can move it into the initialize method. And that way we don't have to repeat it. Okay, now when I do that, notice it now says my index method says, I don't know what the home controller is, because the home controller is declared here. It's not visible outside. So instead, I will do this. I'll declare the home controller globally. So I'll declare it up top globally. We'll instantiate it in our initialize. So this is now moved to test initialize. So we don't need the individual arrange statements anymore. We can just use this same home controller for all our tests. So in my index loads correct view and privacy loads correct view, we can just comment those out. We can just create this once. It's okay to do it in every method. It's just repetitive and unnecessary. The initialize method is designed to save us from having to repeat the same code in every test. So we still need our about method. So we don't need an arrange, we just need an act and an assert. So in this case, we're asserting that our view result.view name is equal to about. So it's the same test as we've already written twice before, but the assert will happen automatically in our initialize method. So initialize will run first and then each test. So if I save and run all my tests again, hopefully they should all pass. I'll scroll up to the top again. So we've added this block at the top of our class, and we've just commented out any of the arrange statements inside the tests. We may still need to arrange things in individual tests, other variables that apply to a certain test, but the controller we need everywhere, so we can just move that to the initialize method. I'm also going to just check my code coverage. So when we were testing the index method, our home controller was 14% covered by tests. We should now be at least 50%, if not more. So I'll run my code coverage analysis one more time. And then we're done with this file. That's interesting. Claire? When you run, okay. And here, are you calling home controller.privacy or .index? So in the privacy test, we've got to call the privacy method. I'm not sure why this didn't pick up our new tests. Weird. I'm going to run my code coverage again. That didn't update. It should have updated. There. So now our home controller, by adding those other tests, it's 42% covered. So privacy is now 100% covered, index is 100% covered, and about is 100% covered. But there's a bunch of other code in the error method, 12 blocks of code and no coverage. So that's why we're only at 42%. So we're not going to make any more changes to this file. Does anybody have any questions about what we've done so far with this set of unit tests? I clicked on the test menu, analyze code coverage, and did all tests. And then it runs them all again, and then you have to like drill way down into that window to get at it. Yeah, to have over 90%, if not 100%. So that way you know, hey, all the things our application could do, we've tested every scenario. So if we go to change it next month, we can then rerun all our tests and make sure all our tests pass, and we're still at 100%. So it's a way of maintaining, not only doing initial quality assurance, but ongoing quality assurance as our application evolves. Absolutely. Absolutely. And normally in larger teams, the quality assurance team is a different set of set of people from the developers. Because the developers, we tend to run things the way they're supposed to work. Whereas if Nick writes the tests for me, my code has to pass Nick's set of criteria. Right? And then you get a lot of that conversation. This is a bug. No, it's a feature. No, it's a bug. It's a feature. Right? We get into that conversation. But it's a way of getting us to think about what is the application supposed to do? And also, how might users interact with it? What might they try that we would never expect them to try? Because we tend to just do things the way our application's supposed to. Right. Any other questions about the home controller? So let's go ahead and test our products controller. Now we scaffolded out this controller. So most of the methods are built by Visual Studio, but we want to start to test them. So I'm going to right click my test project. We'll add let's see, we will add a class. We're going to add a separate unit test project. So we'll call this products controller test. So just a general class. So typically for every controller in our project, we'll have a test controller. And all the unit tests for all the logic in that controller will be in there. And we'll name them the exact same name. We'll just add test on the end. So you have to do this for your assignment. You only have to do this for one of your controllers. You don't have to do it for both. So pick one, make a test controller class. So right now it's a generic class. So we've got to add some stuff to it so that we can do unit tests. The first thing we need is we need to make this class public. Notice the one that we scaffolded out, it has the public declaration. Without public, the unit test won't be able to run any tests inside. So we'll make this class public so the unit test framework test can be run. That's number one. Number two, all the references that were in our home controller test class, we need those same references. So I'm just going to copy these, go and copy all of the using statements from our other test class. We can take those out. So we're going to need all of those. We'll need a test initialize method because we want to write a whole bunch of tests for testing our products controller. Every one of those, we need a product controller object. So we'll just create that globally and instantiate it. So products controller. And then we'll do a test initialize. So we're going to try to run this first. We'll come back to this error in a minute. And we'll write our first method. So we want to unit test the index method in the products controller. So I'm going to open up my web project. We'll open up the products controller and we'll have a look in there. I know we've got this error. We'll deal with it in a bit. So here's our index method. So how many tests should we write in order to properly test our index method? So that's, we go here. I probably have to log in to see it. I think we made it private. Oh, no, we didn't. So we'll just wait. We'll look at our results in the browser at products index. So we basically want to unit test the method that populates this. So here's our method, highlighted. How many unit tests should we write? Remember, each test is going to check one and only one thing. Okay, what tests would you propose we might need? Okay. Okay, so we're going to want the same index view loads test we already wrote, that if you call products index, you get back a view called index. Yeah, and we want to make sure we get a list of product data back. So we're going to have two separate tests. That index loads correct view and index loads product data. Because those are the two things that are happening here. So we'll need two separate tests. But now we've got a bit of an issue here. And the issue is this. It says, so this line of code, this worked fine in our home controller test. We declared an instance of the controller and we just initialized it here. So why do we get a red error in this file when the exact same code in our other test seemed to be fine? What is this telling us? There is no argument that corresponds to the parameter context of the product controller. Joel? That's exactly right. Let's go and look at our controller up here. Can you explain what's happening here a bit more? Right. Whenever we create a product controller, we have to pass it a database connection object. The product controller can't work without a database connection, is what this is telling us. If we look in the home controller, do we use the database at all? Is there any reference to our database here? No, you don't see the word context or DB context at all here. Our home controller, these are just static files. They don't need a database. So our test, we can set up our test here without the database, no problem. But when we scaffold a controller, Visual Studio makes a reference to our database object. So we can't work with the product controller without also handing it, saying, here you go, here's a database connection. I think we talked about dependency injection last week. This is dependency injection. If you want a product object, you have to give it a database connection object, or the product controller can't call any of the methods because every method in here talks to the database. So now we've got this issue. How do we talk to the product? How do we test our product controller without a database? And it's important to note, we don't want to connect to our database here. Because if we connect to the database, we're no longer writing unit tests. Those are called integration tests. How does our application work with our database, which is a separate application altogether? How do they talk together? So we want to split these up. We want to test the individual logic. Does this method return data and does it load the right view? But how can we do this without our database? That's where all the products live. We can, but the reference that we have, we only have one database object right now. And that's, here's our context, right? So we scaffolded this out. And if we go and look at startup, anytime you use this, startup automatically attaches our database with our default connection. So if we use this object, it's going to be connected to SQL Server. We want to test this in isolation with no connectivity. We should be able to go and test this on a dock at the cottage where there's no internet. If we have, so what can we do instead? We need a database, but we don't want the actual SQL Server database. We want to split it temporarily while we're testing. So how might we do that? What would be the solution? Okay. Pardon? That's right. Good suggestion. The unit testing framework, it allows us, so notice here in our startup, when we create the database, we set options, right? And the option is when our application's running in the browser, we're using SQL Server. There is also, if I hit dot, so we've used this option, SQL Server, but for unit testing, we want this option instead. We'll use a local in-memory database, only for testing. We're basically going to mock up a mini version of the product table in memory. It's kind of like local storage, which I know you're all familiar with in the browser. We're going to do local storage of the database so that we can unit test the logic without having to actually connect to SQL Server. So we'll make a note in here. We'll need to use an in-memory DB context instead of connecting to SQL Server. So this will be similar to HTML local storage. So we're just going to create some fake data in memory while we're running our tests. And we'll use that data to evaluate all the methods in the controller. So in order to do this, we're going to need to reference. So our web project has a dependency on Entity Framework Core. So we're going to need a different Entity Framework Core package in our test project. We don't need SQL Server. So I'm going to go back to my test project. I'm going to right-click it and go to Manage NuGet Packages. So if we search here for the word in memory, again, I'll put this reference up on Blackboard. We want this. So our web project uses Entity Framework Core SQL Server. Our test project will use Entity Framework Core in memory. So it's a substitute. So I'm going to select that package and we'll install it into the test project. So this will allow us to basically mock some product data. Oh, wrong version. Sorry, I should have picked 2.26. Don't install the latest version 3. Hang on, I gotta remove that and redo it. So I'll install. So I'll just add to our list of packages. There's one other one we're going to need. So before we can create an instance of our product controller, we're going to need to create a new DB context object that uses the use in memory option instead of the use SQL Server option. So in here, we'll have a, let's see. So we want to create an instance of our database class, and our database class lives in here in the models folder. So we have a reference to the controllers. We're going to need to add a reference to the models as well, but we can let Visual Studio generate that. So here will be our mock DB object. So when I declare it, I'm going to get an error saying it can't find our Control-Alt-PC context. Do we want to make a reference to the models namespace? I'll accept that. Or we could just manually add the models up here. I'm getting a little suggestion down here that also suggests we should make this private, this field read only. I don't have to do that, but I will. Private read only. So we're going to set the options up for our connection. So we're going to use our in-memory database. I know it's throwing an error. That's okay. So it wants a reference in order to fix this error. So just accept the reference to Entity Framework Core. So that was one error. There's a second reference it wants. Is add a reference. I think we're going to have to add this NuGet package as well. And I'll explain why. And I'll put this on Blackboard for you as well. Here's why. In our Control-Alt-PC context, notice we added this when we did authentication. We've said this class connects to our database and it's also used for managing identities. So we're missing a reference. We can't use it without that reference. So I'm going to go back to NuGet. So it wants ASP.NET Core.Identity.Entity Framework Core. So I'm going to add that reference as well. And I'll put this on Blackboard as the other NuGet reference we need. So I'll manage my packages. And if I search for identity, well, we'll make it simpler. This one. Microsoft.ASP.NET Core.Identity.Entity Framework Core. And I'll install 2.2.0. So I will add this to Blackboard as well. So all of these packages, we're going to do unit testing. So these are here for you on Blackboard. That should be the last package we have to add. Yep, just to the test. The only things we're changing in the web project are in those return statements, we're adding the names of the views. Other than that, we're not touching the web application at all. That's the only thing we have to change. Everything else is in the unit test project. So once I install that, this error goes away. So we've set up the options, and now we just need to attach the options to our database object and inject the database object into our controller. Whoops, sorry, that's too far. So this actually creates our in-memory database here on line 28. Line 24 is setting up the options that it's an in-memory database. And line 28 actually connects to our fake database. So then we want to use dependency injection. So now when we create a product controller, we say, here you go, here's a fake database. Because the product controller cannot work, cannot be created if it doesn't get a database object. It has to have it. So now we should be able to write our tests for index. So we said we'd need two tests. One to check it loads the correct view, and a second one to check it loads product data. Public void index loads correct view. We don't actually need any arrange statement because the arrange is all done in the initialize. It creates the product controller and gives it the database object it needs. So we can just act and assert so we'll call the index method. We'll cast the iAction result we get back. Now this code looks the same, right? Here was our, let's just see, our index loads view. We called index, we got back a view result. But notice, now we get an error. Well, this is kind of bizarre. What's the difference? Why does this one not? Okay. So let's look at the difference because the code's identical in these two tests. Call index, cast it as a view result and check it. But this line is okay here, yet it's failing here, which is a bit weird. If we go to the home controller, we returned an iAction result. In the index method in our product controller, the method's a little bit different. What's different about these two? So here's the product index that doesn't work. Here's the home controller that does. There is a return view. It's actually in the first line here. Let me just copy this so we can look at them side by side. Oops. So this one is from the home controller, and this one is from the product controller. What's different about them? Yep, Larry said it. Right, so when we scaffolded the product controller, it automatically is using asynchronous code, which is something we'll talk more about in January. Right? So we have async with a task of iAction result. So the method signatures are a little bit different. This is synchronous code, and this is asynchronous code. So we have to just do a little manipulation. I won't get into the asynchronous part for today, but that's why the results are different. If we just add this, this will handle the asynchronous part. We'll add on a dot result. That basically means once the code is finished, so now we can run our test. Will it load the index view? Let's try it. So I'm just going to run this one test. We'll take a break in a minute. I'm due for some caffeine. And my test is not running. Okay, what's going on? We made our class public, which it needs to be. Oh, we created as a regular class. I forgot something very important. We need this test class annotation. Without it, the unit test framework doesn't know that these are tests. So this was our home controller test. I missed this. The very top of our product controller test, we need test class, or the tests don't run. So as soon as I add that, notice it runs. It failed. Why does it fail? We expected index. We got back nothing. So we need to make the same change to our index method in the controller. So with our home controller, we specified the names of all the views. In the products controller, that's missing. So on line 26, and notice it gives us the red X's, which is kind of useful. It says, hey, you've got, this is covered by a test, but that test doesn't pass. So you need to either change the test or change the method. So we need to do something here. What should we do on line 26 to change our code so our test passes? Okay, so we're already returning some data. So where should the name go? Instead of this, before it, or after it? Well, let's see. If we hit return view, so it says there's 3 overloads. So this one is return a view and send it some model data. The first version is return nothing. The third version is the view name, but we need both. The name, we also still need the data, otherwise our page will be blank. So here it says the view name, if you want to provide both, the view name is actually the first parameter and the data is second. So right at the beginning, we can just put in index and a comma. So first return the view name called index, and second return the model or the data. So if we save that, I can build, then I can run my tests, and notice the live unit test, it already passes. So the only thing we've changed in our controller is we've added the name of the view before the model in our return statement. Any questions so far? I realize this is new for everybody. Anything we've done that doesn't make any sense at all? So what we are going to do, I will push this code. I think we will have to skip our lab, but what we will do is, so we've tested, we've set up our database, but we haven't actually done any testing using our in-memory data. So we want to create some fake product data, and then we want to try testing as many of the methods as we'll be able to test in the time we've got left. We'll definitely want to test index and details. We'll be able to get those done for sure. We may not get to do create, edit, and delete. Whatever methods we don't cover in class, you don't have to do in your assignment. So if we only get index and details done today, I'll update the assignment so you only have to do index and details on the assignment, okay? I won't ask you to do any kind of unit tests that we don't do together. Okay, so we'll take a break. We'll come back in about 10 minutes and we'll see how much of the controller we can do with the time we have left. I will upload all my code.